The last question on the molecular methods handout asks about a Western blot. So for the Western blot, we're going to be thinking about the properties of the proteins that result after the alleles described have been first transcribed into RNA and then translated into protein. So let's think about what the proteins will look like from those different alleles. First of all, the wild-type allele is going to result in a full-length protein. We don't know exactly how many amino acids it is because part of this RNA is going to be UTR, but we can say that this is going to be the longest possibility. This will be full-length, unaffected by any mutations. Now the B allele, because of the deletion, assuming that the deletion actually includes some coding region and it's not all UTR, is going to result in a shorter protein. With the A allele, there's two possibilities. First, it could be a missense mutation. If it's a missense mutation, it's just changing one amino acid to a different amino acid. And changing the amino acid does not affect the length of the protein, so this would also result in a full-length protein. The second possibility is that it's a nonsense mutation. If it's a nonsense mutation, then we've changed a codon for an amino acid to a stop codon. Now, since the stop codon, assuming it's a nonsense mutation, is very early on in our gene, this is going to result in the shortest protein that we would see, even shorter than the deletion allele. So if we're going to do a Western blot, we're going to need an antibody that's going to recognize our different proteins. Antibodies usually only recognize a few amino acids out of the protein, so in order to have a chance of an antibody that would recognize all these different possibilities, the antibody would have to be recognizing those first few amino acids that come before the point of that potential nonsense codon. So now let's look at a gel and look at the four different possibilities that we have. First possibility is Bob, homozygous wild type. Then we have Irene, heterozygous for the deletion. Then we could look at Jim if it was a missense mutation, and Jim if it was a nonsense mutation. In either case, he's homozygous for that point mutation. So the longest protein is going to be present in Bob. This is our full-length protein. That would also be present in Irene because she's heterozygous. And we would also see a band at that point in Jim if it's a missense mutation, since the missense mutation maintains a full-length protein. In Irene, we're going to see a band that's shorter because she has that deletion allele, so we'll see two different bands in Irene. And then the shortest band of all would be seen in Jim if it's a nonsense mutation. So that shows the possibilities for what a Western blot would look like for these different alleles.